let's review some code. Welcome to another DeFiChain video. My name is Kügi, and today we will be a bit technical again. I want to show you a small Python code, a small Python bot that could be used to implement the current special DFIP about the community fund diversification. Why do I say it could be used? Because right now there is some discussion going on and we see what type of bot do we use, what technology. We are trying to get some feedback from the core team, where do you run the bot and so on. But this is one option, and I thought it might be interesting for the one or other to get a bit of an insight how such a bot looks like and what it does and how it works. Everything is open source in the repository. I will link that in the description. And just a quick disclaimer or warning, will be pretty technical today, will be into coding. I try to make it not too deep. It's also not a too complicated bot, so might also be interesting for people who don't know how to code or don't have anything with Python or anything. But if you are into it and if you want to get a first step or first idea where to start to run a bot for DeFiChain or on DeFiChain, this might be a good start. So follow along. About the whole thing, if you look at the repo, in there are two folders. One is Python and the other is Ocean, because I started the whole thing as an Ocean bot, which would be run as a Lambda in AWS and interact with Ocean, so no direct fullnode access or anything. I honestly didn't finish that part because then Bernd came along and said, okay, if they run it within my DeFiChain, it would be next to a full node as a Python code. So I switched and made a small Python sample that's in the Python folder, and there the bot is basically done and can be used directly. I already tested it on testnet. So that's just about the structure. Generally, what should the bot do? It's pretty simple, actually. It's just about have some DFI in the address, decide how much DFI to swap to the USD, and swap the DFI to the USD so that they end up in a community fund. That's basically the goal. There are some conditions, like we want to swap maximum to 30% of the community fund, so the value of the USD in a community fund must be below 30%. So we don't swap if the USD in the overall community fund funds are already at or above 30%. Maximum 5,000 USD DFI per block, and the impact on the price must be a maximum of 0.1%. So that's the parameters, and the idea is that the core team will send funds from the community fund in a regular batches to this bot address. The bot there swaps it and swaps it basically back to the USD into the community fund. So that's the rough idea, so that we don't have too much funds on this bot address all the time, because it's always a bit of a risk to run a bot on that address with a lot of funds. You never know. I mean, it's a simple bot. There's not much that can go wrong, but you never know. So never risk too much. And that's the overall idea, to have that kind of flow also with security and everything. So let's look into the code and stop the talking about it. First, yes, this is not my real username or password on my node. It's just, honestly, this is a joke in the security industry. I honestly don't remember where it came from, but yeah, I always have the sample password as Hunter12 and Satoshi, this makes sense for most of the users. So localhost and 8555, I think it's the default for the desktop wallet, the desktop app. The full node running on the desktop wallet is expose RPC at 8555. So you could keep that, but yeah. Then what do we have in this bot or in this? It's, as I said, it's a Python script. I kept it as small as possible because I just wanted it to be easy to understand and maintain. I think Bernd will add some monitoring and everything to it. So in total, it's just 209 lines of code, and it has already some logging and all that stuff in. And I will kind of skip the boring stuff, say it this way. We have a small settings class just to read the settings and then have it. Here's a sample settings file where you can put in where to find the node, what user and what password to use for the RPC. Should we log to the console? Should we log to a file? What's my bot address? What's the community fund address that should be used? What's the maximum swap per block? What's the maximum percent move? The target ratio, the block period, and a force start, which means it will directly start and not wait 20 blocks and then one every 20 blocks. So that's just the sample, the settings, and you can, that's how the settings will then be put in there. We come to that in a minute. Then, setup logger, I will not go into that. It's basically just boilerplate. How to set up a logger in Python. It's a standard logging package on the one hand for a file handler, and on the other hand for the console. If you log to console and if you log to file, we have the folder with the logs and the rotating file handler that just adds files and logs there. So we have a good logging there. Not much to see here. Then read settings, also not a big thing. We have the global node URL parameters or functions, variables, and they are here for the RPC method. Come to that in a second. And in the read settings, we are just opening the settings path that we get, load the JSON from the settings, so this JSON, and then set our global parameters, and then read the settings into the function, into the class that we had before. And that's it, reading the settings from the path to the settings object. The RPC is now a bit of an interesting method because this is the method that encapsulates the connection or the talking to the node. A DeFiChain node, if you have it running, the full node, which is also in the desktop wallet, is from the interface like a standard Bitcoin node, which opens an RPC interface, and you can directly access it with JSON parameters. So you send it basically a JSON with this stuff and with the method name that you want to call in the CLI and the parameters encoded that you want to add to send to this method call. And then we can use the standard requests package in Python to just send a post request to this RPC node URL with the basic authentication, user and password, and send the data that we encapsulated here. And if we have an error, we log the error and we return from the JSON result. The result is our return value. So this is just a method that we can now call and give it the method and the parameters, and this is directly sent to the CLI basically. So that's our RPC CLI call. I know there are Python libraries which encapsulate all that and make it easy to use and everything. In this case, I didn't use any of that on purpose to show how simple it can be if you have just a few calls that you want to do, because then you don't need to rely on any third-party library, trust any third-party library, and maybe basically just do your thing. Then there's a bit of a helper functions. On the one hand, the wait for transactions basically just gets the current block count, checks if this transaction gets the transaction, sees what's happening, and while the transaction is not confirmed, so there's no block hash in the transaction, it's just waiting, sleeping for a loop count, and goes through the loop until the transaction is confirmed or the block timeout is gone. So this is just, again, a small helper that helps you to say, okay, if I want in my main function to wait for a transaction ID to be confirmed, just do that, and it just awaits in there. And then it starts to get a bit more interesting. We have the token balance, the get balance for an address. And here it's one thing about UTXOs versus tokens. In DeFiChain, we have the UTXO system, like it is with Bitcoin, and we have the account balance, which is a balance system, same as we have it in Ethereum and everything. And we have both. We have on the one hand the UTXO level, and we have the account level. And you can do a UTXO to account and account to UTXO for DFI, and all the tokens are only on the account level, right? So on the token level. And if you want to get the balance on a UTXO level, you basically need to get all your unspent transactions, so all your UTXOs, and sum them up. In the wallet, the node does that for you for your whole wallet. So you can say get balance, and then you get your balance for the whole wallet. But if you have more than one address in this wallet, it sums it up already. So if you want just for one address, you need to get with list unspent, get all your UTXOs, and then sum them up. Just run a reduce over it to say, okay, my previous wallet plus the UTXO amount, start with 0, and apply that to the UTXOs. So it's basically just summing up all the amounts that I have unspent, and that's my balance. All my UTXOs in the address. And difference on the tokens, if I can say get account for this address, and I get back a map, a JSON object with it's a JSON array with a list of strings, balance at token ID, and we just split that up and make a map out of it so we can easily read it. And here you don't have to sum up UTXOs or anything. You get directly DFI token, that amount in the address, USD token, that amount in the address, and so on. So that's far easier with the account stuff. Now, maybe skip to the how we call it. So if this script is called directly as the main function, we just go in. The signal handlers are just here, that if you skip it, interrupt it from the command line or anything, it stops gracefully and not needs to be killed, right? And it reads the settings path from the command line arguments, prints that, reads the settings from this path into the object, sets up the logger from it of the function on top, checks what is my start block, because the get block count CLI method tells you the current block basically, because the block height. If we have a force start, we set the last block to 0, because then this condition to only run 20 blocks after the last block is always true then. And then as long as we should run, so as long as there's no interrupt happening, get the current block, check if the current block is more than the block period since the last block. If yes, we're executing at this block, execute the main loop with the settings, save that we are executed, and then log that we did it, and wait for 10 seconds and then check again what's the next block. So that's our main loop. That's just some preparations, reading the settings, and then run the main loop of the stuff. I know there are nicer ways to do that with IO handling it or with loop handling and everything, but I thought stick to plain or good old Python, so that it's a bit easier for everyone to understand. But if you know Python and think we can do that better, or there are improvements, feel free, open a pull request, would be happy to see that. Now let's look into the main loop method, and that's here. As you see, there's a bit of a logic in there, but don't worry, not that much. So first thing, get the balance from the current address, from our bot address, and if we have more than one in UTXOs, so we keep one for fees and everything, but if we have more than one, it means that we likely got a rebalance, or we got funds refueled from the community fund in, and we need to move them from UTXOs to tokens so that we can swap them. And here is one warning, because from what I saw and what my experience is, I tried everything basically. The UTXOs to account method always takes random UTXOs from your wallet. So you can't really tell him to take the UTXOs from exactly that address and only that. Even if you tell him exactly UTXOs to use, the node ignores it. So either you build the custom transaction yourself, and I didn't want to do that here in this context, or it takes random address UTXOs from the wallet, which is no problem if you have only this address in the wallet. If you have multiple addresses in that wallet, it might mess up your addresses. So that's why I added the warning here that this takes that, and maybe build the custom transaction ourselves. But for now, we will likely run that on a clean wallet anyway. So if we have that, we say in the parameters, in the params, we need an object with the target address and UTXOs -1 to 8 digits, because we are only 8-digit possible, and add DFI, because we want DFI converted, and we send that to the node, wait for the transactions, and get the balance again to be updated with the balance, just to have that on the safe side. Then we have a lot of balance reading. First we get the pool, the DUSD DFI pool, get the ratio from the pool, and with that calculate what's our max swap, because reserve B is the DFI, so that it maximum moves by this percentage. That's the calculation for that. I will not go into that math now, but it's basically from this reserve A times reserve B is a constant. If you take that and calculate the ratios and everything, you come to this formula. So that's the max DFI that we can swap in to move the pool by, in this case, 0.1%. And then we have a lot of balance getting. How many DFI do we have in the community fund? Get balance, community fund address. The tokens, then have the DUSD in the fund, DFI token in the fund, get the DFI from these tokens. Also the community balances, and now this is an important or interesting part, because until the Greater World fork, I think, the community fund was always UTXO paid to the community fund address, right? And since then, it's no longer paid to this address, but it's accumulating within the node in a community balance account, which is just a number in the node, right? Or in the system, on the chain. And this is shown if you call the list community balances. There is this entry community development funds, and there the number goes up with each block. So we need to add that to the calculation about the community fund. So we get the DFI community from this number. Now we have the community fund balances. Then we also take our own balances, because this address, the spot address, now belongs to the community fund. So we need to add that to the calculation. So we get the DUSD there, and the DFI and the UTXO we already have from up here. We just log that if we are in the debug logging to have some info. And then we can easily say, okay, what's the total DFI in the community fund? It's the DFI from the community, so from the community balances, the DFI in the community fund, the DFI token in the community fund, the UTXOs in the bot address, plus my DFI tokens in the bot address. Then the total DUSD in DFI, and here we have now the DUSD in the bot address, should be 0, but you never know, so safety sake. And the DUSD in the community fund, what we already swapped there, times DFI per DUSD, because we want to have this value in DFI, because then we can say 30%. And then we know how much DFI from the fund we should swap to the DUSD side, or then for the 30%, how much DFI are left to be able to be swapped to the DUSD side. And then we have the max part in DFI. What as I just said, we said the total DFI plus the total DUSD calculated in DFI current value times the target ratio. That's the max DUSD part in DFI value, because that's what we want in a total, right? And now we say, what's my swap amount is the minimum of the max part that we have minus the total DUSD that we now have. So that's the remaining DFI that can be swapped to DUSD based on the 30%. Then the max swap per block, because we don't want to swap more than that, or the max swap for move for this 0.1% move, or the max DFI that I have, because the bot shouldn't try to swap more than he has in the account, right? So that's our stuff. Also again a log debug, and then if the amount is greater than 0, we do a simple pool swap. Pool swap from our address, from DFI token, amount is this amount, to the community fund. We directly swap there, so we don't need to move funds after the swap, just swap there directly and they get the DUSD. And token 2 is the DUSD, so it's a pool swap, no composite swap on purpose, because we always want to swap directly in a DeFi DUSD pool to have no impact directly on the DeFi price, just conversion DeFi DUSD. And yeah, we are in the end saying, okay, swapping, and then we are through. And then 1-1 is through, and that's it. So with that, I hope that helped. I hope that gave a bit of a clarity, a bit of a how can you do such a bot. As you see, it's not that complicated. Maybe someone gets motivated to do that, or to improve that, or to do one for themselves, or look at the code and review it and leave some comments. If you like that, leave a comment. I guess this video will not be viewed by so many because technical reviews are always a bit boring. But yeah. Anyway, I hope someone got some value out of that. And with that, let's see if the DFIP is even approved. If not, the whole thing is just, yeah, fun practice. And if it's approved, let's see when this bot gets live. With that, see you at the next video and happy coding.